Okay, so we would like to find a potential for the conservative vector field 3x squared y squared minus cosine x on the first component and 2y plus 2x cubed y on the second component. And what that pretty much means is we want a scalar function that has this vector field as its gradient. And even though it's not asked of us to check that this is a conservative vector field, it might be a good idea to give a quick justification. So first of all, we have a vector field which is defined on all of R square. And if we take p sub y, we see that this is equal to 6 x squared y. And if we take q sub x, then we see that this is 6 x squared y also. And in the case of R squared as the domain of definition, this condition is also sufficient, which means that this vector field has to be conservative. But in any case, what we do is we get a first guess about what the potential could be by integrating the first component with respect to x. So that would give us the integral of 3x squared y squared minus cosine x dx. And we should emphasize here that in this integral, y is treated as a constant. So this will simply give us x cubed y squared minus sine x. And here's the crucial point where we don't put plus c, but we understand that since this entails partial differentiation and partial integration, if you will, we actually, partial integration should not be used in this sense because it's usually integration by parts. But in any case, the bottom line is that the constant is interpreted as a function of y. And it's exactly this function of y that allows us the flexibility to make sure that the partial derivative of this with respect to of what we just found with respect to y is going to give us q, which is really the requirement. Because having integrated that with respect to x, it's guaranteed that the partial derivative of this with respect to x is p. So that's perfectly fine. But we also want the partial derivative of this with respect to y to be equal to the second component. And what this means is that 2x cubed y, that's the partial derivative of x cubed y squared with respect to y. Derivative of negative sine x, of course, 0, and then the derivative of g of y will be simply g prime of y. That should be equal to 2 to the y plus 2x cubed y. And of course, the magic here is that this cancels with that, which leaves us g prime of y being an expression of merely y. And of course, we need an antiderivative for 2 to the y, which is 2 to the y over ln 2. I mean, to know that this is the correct antiderivative, you just need to remember that the derivative of 2 to the y is 2 to the y ln 2, which means that if instead of 2 to the y, you differentiate 2 to the y over ln 2, the ln 2's cancel each other and you simply get 2 to the y. So let's recap the potential, or one of the possible potentials that we needed is x cubed y squared minus sine x plus 2 to the y over ln 2. And that's all. Thanks for watching.